Lesson 8.5 is still dealing with rational expressions, except instead of simplifying, multiplying, and dividing, we're now adding and subtracting. Okay? So there is still a great deal of factoring involved. Okay? We still have to be able to factor, but how do we add and subtract fractions? You have to have... We have to have a common denominator, don't we? In order to add and subtract fractions, we need a common denominator. Gosh. So we have to talk about common denominators. Now, in order to get these common denominators, we're still going to be factoring. Okay? It's still the baseline of the name of this game is factoring. So, an example here, and it's not the greatest example, but in order to add 4 over x squared plus 3x plus x minus 2 over x squared plus 6x plus 9, you have to factor that. In order to find your common denominator, you have to factor them. And so x squared plus 3x, that's a GCF factoring. So you factor on x there, and it's x times x plus 3. X squared plus 6x plus 9, that's product and sum. So x plus 3, x plus 3. With the idea of those two denominators, your common denominator includes everything that the given denominators have in common. So anything that's ever in the denominator is part of a common denominator. Well, you'll notice there's an x here, yes? So there's an x in your common denominator. You'll notice there's an x plus 3 in common, yes? There's one x plus 3 in common, so there's one x plus 3 in my common denominator representing what's in common. And then over here you have an extra x plus 3. So my common denominator has an extra x plus 3. And so you have all those pieces that make your common denominator. And then it goes back to the basics of, okay, how do we add and subtract fractions when getting with that common denominator? Okay, and I don't know, I'm half tempted here to throw in one on the side here. Let's see. Okay. Going basic here. How do we add 1/2 and 2/3 without just punching it into the calculator? How do we add 1/2 and 2/3? What kind of common denominator do I need here? Because 2 times 3 is 6, right? So we're multiplying together our denominators. If this denominator is 2, what do we do to get 6? Multiply by 3. What you do to the denominator? You must do to the numerator. 1 times 3 is 3. 2/3. How do I get 3 to be my common denominator of 6? Multiply by 2. What do I do to the denominator? We do to the numerator. 2 times 2 is 4. Does that sound a little familiar? Maybe you don't need that. Maybe you're looking and saying, really, Mrs. Sargent, I did not need to see that. However, some of you are saying, oh, yeah. What is 3/6 plus 4/6? 7/6, right? Okay. So, let's go over and look at example A. What is the sum of each of the following? In simplest form, state any restrictions on the variable. So, as we look at this, always start by looking at your denominators. Is there anything that can factor? Does x minus 1 factor? No. X minus 1 is just x minus 1. Does x squared minus x factor?
Yes.
It does. How do we factor x squared minus x?
X parentheses x minus 1 parentheses.
Okay. Think GCF. Does that ring some bells there? I can't do a product and sum here because there's no number term, but x and x squared have a GCF of x. So right underneath this, I'm going to factor out an x. If I factor out an x, that means I'm going to put the x out front. X squared divided by x leaves me with x minus x divided by x leaves me with 1. So this factors out to be x times x minus 1. Now, common denominator. I have this denominator of x minus 1. I have this denominator of x times x minus 1. Common denominator is all of the pieces represented. Okay, I want to say all the pieces taken care of, but all the pieces represented. And so as I set up my two fractions, which is what I like to do here, okay, common denominator. Is there anything that both fractions have in common in their denominators?
X minus 1.
Okay, can you see they both have this factor of x minus 1? So one part of my common denominator is x minus 1. Anything else they have in common? It's just the x minus 1, right? Are there any other leftover pieces then that weren't in common? There's an x, right? So my common denominator is going to be x times x minus 1. X times x minus 1. Because there was an x minus 1 in common, I started with anything that's in common. And then there was a leftover x. Now, I need to get that common denominator, right? So this is like we decided the denominator over here was 6. 2 wasn't 6, so we had to multiply to make it 6. 3 wasn't 6, so I had to multiply to make it 6. First fraction. Is x minus 1, that's what's currently in my denominator, is that my common denominator? No, my common denominator is supposed to be x minus 1, isn't it? So what am I missing from this denominator in the first fraction that I have down here? I'm missing an x. So we're going to have to multiply this fraction by x. What I multiply by the fraction on bottom, we're going to multiply by on top. So because x was a part of the common denominator I was missing here, we're multiplying by x. On bottom, notice x times x minus 1 is my common denominator. On top, I'm just going to leave it for right now. I'm going to write it as there's an x, and then there is an x plus 1. I'll work to clean that up in my next step. If on top you want to go ahead and multiply that, you can. Now, second fraction. My original denominator in factored form was x minus 1. My common denominator is x minus 1. What am I missing? Am I missing anything in the common denominator here? No. This is the common denominator. X minus 1 is the common denominator. So this fraction isn't going to change. My common denominator carries down. Guess what happens with the negative 2 on top? It carries down. If there's nothing to multiply by, nothing to change, it just carries down. Now, how do we add fractions? We need a common denominator, which, what did I just get? A common denominator. So we need a common denominator. So when you're adding fractions, you keep the common denominator, right? What did I do over here with my 6? I kept the denominator of 6 and added my numerators. So I'm going to keep my common denominator of what? X times x minus 1. And then I'm going to add my numerators. Okay? In the numerator, you do tend to multiply, you do tend to distribute. So before, as I add these, I'm going to go ahead and distribute this. So what is x times x? x squared. X times 1, 1x, or just x. And then plus, what else do I have in my second fraction? Negative 2. Which plus negative 2, are you guys okay if I write minus 2? Now, we are possibly done. There's a possibility we need to simplify. And this is what you always need to check. If nothing is going to factor and cancel, you could leave your answer like this. What you need to check at this point, though, after you get your fractions added together, can this numerator factor, and if so, does something cancel? So, does x squared plus x minus 2 factor? Yeah. So we need to factor it and see what happens. I wrote too big up above, I guess. I know. We'll get it. We'll get it. Okay, denominator is already factored. That's x. X minus 1. Numerator. Are you realizing my numerator factors into 2 parentheses? X squared breaks into what? X and x. What multiplies to be negative 2 and adds to be 1? Plus 2 minus 1? Yeah. Because if it multiplies to be 2, it's some combo of 1, 2. If it multiplies to be a negative, I need a plus and a minus. If it adds to be positive, that bigger number is positive. Well, is that worth factoring? Is something going to cancel? Yeah, it is, isn't it? Okay, so if you would have entered this previous answer, MathXL would have counted you wrong. Okay, because this factors, and more importantly, what cancels? X minus 1 on top cancels with x minus 1 on bottom. What remains for my answer?
X plus 2.
Okay, there's an x plus 2 on top, and there's an x on bottom. Do those x's cancel? No? Why not? Because they don't want to. Okay. On top, it's not just an x, it's an x plus 2. So that x that's part of the x plus 2 would have to have another x, just a plain x to cancel with, if you know this x would. So your final answer here is x plus 2 over x. Now, before I forget, I honestly did kind of forget, it's still a thing this chapter or this lesson. Restrictions on the variables, or on the variable. How do we find restrictions on the variable? What? Set the denominator equal to 0. Okay. And I, of course, would use my factored denominator. You don't need a whole lot of work to show this, or a whole lot of room to show this work, because basically I would look at your common denominator here. My common denominator had a factor of x and a factor of x minus 1. If you set x and x minus 1 equals to 0, what can x never equal? X cannot equal 0 and 1. So there are 2 restrictions on the variables. Okay. We'll obviously be going into B more tomorrow, but first step is getting that common denominator, yes? Before you get your common denominator, what am I going to tell you to do? Factor, right? factor your current denominators. Does x squared minus 4 factor?
Yes.
Sure does. Actually, did I factor x squared minus 4 earlier?
You did x squared plus 9.
It was x squared minus 9. That's what it was. Okay. So x squared minus 4. X and x. Square root of 4 is 2 and 2. Plus and minus. Okay. Thoughts on what that common denominator is going to be tomorrow? The x plus 2 is in common, and
The minus 2.
there's an x minus 2. So, okay, we will pick up tomorrow. Come in ready to work tomorrow, guys. We've got to add. Good news is we get down to subtracting, it's not a whole lot different. And then we've got to look at dividing complex fractions on the back a little bit. So, we won't do all the examples, but we'll go through what we can.